Hello all. EfectroH2O is an interdisciplinary project that demonstrates the efficiency of electrically driven water treatment processes to remove salts and micropollutants from textile wastewater. It involves a combination of capacitive deionization (CDI) and advanced oxidation process (AOP) for a low-energy zero-liquid discharge textile wastewater treatment technology. It is funded by the Federal Ministry of Education and Research and the Indo-German Science and Technology Center within the 2+2 program. The textile industry alone contributes 5% to the country's GDP, 7% of industry output in value terms, and 12% of the country's export earnings. Textile production is estimated to be responsible for about 20% of global clean water pollution from dyeing and finishing products. Wastewater discharged from textile industries contains a wide variety of biodegradable and non-biodegradable chemicals such as dyes, dispersants, leveling agents, heavy metals, dissolved inorganics, acids, and alkali. The discharge influences the aesthetic value, water clarity, and solubility of gases in lakes, rivers, and other water bodies, decreases photosynthetic activity by hindering light penetration, and in addition, delineates toxic impacts on aquatic organisms. These dyes cannot be degraded easily and some of them are hazardous to humans and other living forms. Since the wastewater discharged from textile industries has critical ecological impacts, the textile industries were forced to implement zero-liquid discharge to eliminate any discharge of wastewater into the surrounding environment. Certain challenges need to be addressed. The capital and operating cost of ZLD is very high compared to conventional treatment methods. Owing to this, processing cost of dyed fabric increased from 1.9 to 4.37%. At present, several R&D efforts are ongoing to address the challenges of the existing ZLD treatment. This project aims at improving the process of water treatment in textile and other industries. The objective is to improve the techno-economic feasibility of zero-liquid discharge (ZLD) plants by recycling process streams and recovering resources, such as salts. To achieve the goals, we have utilized a synergetic combination of advanced oxidation processes (AOP) and capacitive deionization techniques. EfectroH2O consists of two main building blocks: treatment technology and analytical methods. In close collaboration, both areas will feed back to each other, leading to synergetic effects by integrated development of treatment technology and analytical methods. An advanced oxidation process followed by capacitive deionization technology is used to remove organic pollutants and salts from textile process wastewater. The electroperoxone process can provide a convenient and efficient way to degrade the dyes and other organic pollutants effectively. In this process, pure oxygen is obtained from an oxygen concentrator and passed through two lines, one for oxygen supply to the reactor and the other for ozone generation. Apart from the oxygen and ozone inflow, an electric potential is applied to aid the in situ generations of hydrogen peroxide. The in situ generated hydrogen peroxide reacts with sparged ozone to produce hydroxyl radicals which oxidize the refractory organic pollutants present in wastewater. A typical CDI cell consists of two electrodes which are made of a porous conductive material that allows access for ions and has an ion storage capacity. In the CDI system, a charge is applied to an electrode surface, forming what is known as an electrical double layer with an area of oppositely charged particles. Once the electrodes are saturated with ions from wastewater, they are regenerated by reversing the polarity of the electrodes. The efficiency of CDI cells is improved by using ion exchange membranes which prevent the co-ions from being expelled. These systems are known as membrane capacitive deionization (MCDI). Real textile wastewater was treated by electroperoxone process. The process was able to achieve complete decolorization and 94% COD removal. You can observe the color change visually. The treated effluent of electroperoxone process was then treated using capacitive deionization. A CDI cell is assembled with electrodes, membranes, spacers and gaskets, and tightened to avoid any leak. With single cell in circulation mode, a conductivity reduction of 69% was observed in capacitive deionization process. Currently, stacks of CDI cells are explored to improve the recovery even higher. For future work, the influence of other novel electrode materials in salt removal will be studied in addition to the upscaling of the AOP and CDI tech to pilot stage. This project aims to ensure the availability and sustainable management of water and sanitation for all, as defined in the United Nations Environmental Programme for Sustainable Development.